Myself, Srinivasan, professor in mechanical department at Sri Shimo College of Engineering. I'm going to talk about deep learning. Deep learning is a very important subject as far as computing science is concerned, and not only computing science and other core branches of engineering. So, before going to the subject of deep learning, we should understand what is machine learning. Machine learning is basically a subfield of artificial intelligence, and where we focus on a certain algorithm. That algorithm will try to find some patterns in the data. Okay, so based on the patterns in the data, we can easily predict what is going to happen for the new setup, new test data, I can say. So, in traditional computer science engineer, and what they do is they write some program and try to get some output of it. In machine learning, and mostly we have all data sets with labels, and as far as supervised learning is concerned, and based on the algorithms, we can have at the end we can have a model out of it. So whenever we see a new instant, and we can predict or we can take, that will help us to take decision based on the output that we get from the algorithms. So that's why it is a basic difference between the machine learning and traditional programming. In traditional programming, we get output and we write code and everything, but this is how we here also we write coding, and but basically works based on certain algorithms, and we used to train the data, and for the new instant we get the output. Okay, there is a analogy between how people used to think and how machine intelligence used to predict. Okay, as far as human is concerned, we experience something and we predict something. Okay, so whenever, suppose for example, I can say, based on the experience, we take decisions. Okay, and based on the experience is basically a data, then we analyze, or it goes to our human brain, that thereby we analyze certain things, and based on the experience we take decisions. That's the way human do that. Okay. See, as far as the computer, and what they do is say, in machine intelligence, if you look at artificial intelligence, we have a certain database, and that will have both input features as well as output labels as well. Okay, everything is there. Okay, so we use certain algorithms, and that try to find some models, and whenever we give the new instance, and that will help us to get some decisions. Okay, so that is the way it works. So the analogy is basically, the experience is basically our data. In case of machine intelligence, it is a data. Okay, and humans, and based on the experience, and based on the experience, humans will get some knowledge and skills. Here we get some models. Okay, so that the correlation is here model, and there it is knowledge and skills. And whenever we see a new instant, and we can able to predict, or we can able to take decision based on that. So that is the difference between human and machine intelligence. So now, as far as machine intelligence is concerned, we talk about models. And as far as human is concerned, knowledge and skills. So what is model here? Its model is not only the machine mathematical equation, it also, because we work on numerical values and categorical values and so on, and whatever we are going to see in model is mathematical equation, and sometimes we see graphs and trees, and these graphs and trees comes under non-linear data structures, and some rule-based learning will be there, and if and else, and we group certain data, and based on the similarities and so on. So this comes under cluster category, and whatever we have discussed so far, this comes under the model. Okay. So once we find some patterns in the data, then it gives a model, And that model will help us to find take decisions for the new instance. And today's world, machine learning is widely used in many applications, I can say. Okay. So as far as healthcare industry is concerned, we try to diagnose this because we try to interpret many things. Okay. And it helps in drug discovery as well and patient monitoring and so on. And as far as the business is concerned, it will help us to project what is going to happen in future based on the current and past data. Okay. And natural language processing, we try to it basically works on the text and the speech, and we try to analyze because if you have a critic review and it is helps to find out is it good or bad, and that translation also, machine translation also happens based on natural language processing. Because in our today's world, we have more than 65,000 of languages around the world, and it each has different semantic and structured in the natural languages. And in mostly in US, and we used to see driverless. I mean, there is no driver in the car. There is autonomous vehicle, I can say, based on that sense. Because if you have a driver and they will based on our sensory organs, and we used to drive and the car. And in case of autonomous vehicle and sensors and it will have a it will have a computing systems which helps us to take decisions. So the sensory equipment, means sensory sense. There will be many sensors in the car that captures the data and it gets analyzed in the computers. And there we use machine learning models to predict whether we have to go fast and left, right, and we have to apply brake and everything. It's widely used in autonomous vehicles. So then the recent advancement in IoT, and we use why we use machine learning models in agriculture field. So suppose if we have many acres of land and we have we want to find out some disease in the plant, and we can use this machine learning models to see is there any disease, and then there we can take some corrective action by applying fertilizers. Okay. And social media, so because I mean in social medias, and as I said in the natural language process, if we have is it good or bad, we can analyze using the data. So there are many applications in as far as machine learning is concerned in today's world. Okay. So in this class, we'll little bit talk about deep learning. Here we talk about machine learning framework. Here we discuss how we can convert from data to the predictions. Okay. So initially we'll have some data sets. That data sets will have many features, and we have to work on exploratory data analysis. And the exploratory data analysis basically it tries to find some pattern in the data, and it tries to remove some unwanted features in the data. Okay. So there we use to reduce the dimension, we use principal component analysis, and to find some mapping, that is self-organization maps, which will try to find some pattern in the clusters and data samples. Okay. So these are the things we have to do for the understanding the data. Okay. So once you understand the data, then we have to find out is there any inconsistency. For example, I can say missing values. We have to see is there any missing values in the data. Okay. Or we have to remove the reductant features. Basically, if there are many repetition in the data, that has to be removed. Okay. So once you do all pre-processing steps, that is once you do all pre-processing step, that data is ready for the split up. Okay. So basically what we do in the split up is we take mostly 70-30 or 80-20 ratio, and the 80 goes for the training data set and 20% goes to the test data set. Okay. So once you have the majority of the portion as test training data sets, we apply the learning algorithm. So I can say there are many learning algorithms. We apply regression-based algorithms and tree-based learning algorithms and so on. For example, random forest and decision tree, and these are all tree-based learning algorithms. Okay. So once you then for neural network, we apply neural network also. We can apply to capture the nonlinear pattern if there is any nonlinear pattern in the data. Okay. So there are many learning algorithms. Each learning algorithm will be applicable to will be applicable to certain characteristics of the data. Okay. So if you have the more of linear data, then we can apply the regression-based models. If you find more complexity, you can apply neural networks. So this is the way we work on learning algorithms. Okay. So once you apply all these things and we cross-validate the model, whatever the model predicted by the training data sets. Okay. So we fine tune using some hyperparameters. For example, I can say learning rate is also hyperparameters. The number of slicks in the data is also hyperparameter. So we have to fine tune the hyperparameter to get the better model. Okay. So once you have the better model, we can use that whatever we have expected, that is 20% test data set. That data set can be used for the testing purpose. Okay. So once you test the model and we can able to predict. Okay. So we can compare whatever we have predicted with the actual whatever we have got. Okay. So the the performance metric can be classified into two ways. One is, as far as if there is a classification problem, we can go work on accuracy, sensitivity, and specificity, and so on. Okay. In case of regression problem, we work on R square and mean square error and root mean square. Okay. So the accuracy is basically how correctly you are able to predict. And sensitivity is basically how well the positives are detected. Specificity is basically how well the negatives are detected. So R square is basically it explains the variance in the model. The mean square error, the difference between this predicted and actual one. Okay. So based on this performance evaluation matrix, we can able to see how well that algorithm works. Okay. So this is a way the machine learning models works for the prediction.